Okay, so in this section, 11.4, we are going to start off by talking about different kinds of angles that you're going to see inside of circles. But let's just kind of recap what we've done so far. Back in Unit 10, we talked about central angles. So a central angle, it was just an angle where the vertex was the center of the circle. Okay? And we had a relationship between this angle, theta, and the arc measure. All right, this was the easiest one because whatever this arc measure was, it was the same thing as the central angle. So if we had an arc measure of 95 degrees, then our central angle was also 95 degrees. And then the next one we talked about in Unit 11, this was kind of our new angle, was an inscribed angle. Okay, and the difference between an inscribed angle and a central angle is that an inscribed angle, two sides of the angle are chords in a circle, and then the vertex lied on the edge or on the circumference of the circle. And the relationship between these two was that this central angle, this inscribed angle theta is just half of the arc measure. So if this arc measure right here was 120 degrees, then theta, and this inscribed angle, was just 60 degrees. So that was the main difference we had between central angles and inscribed angles. Now, what we're going to talk about are some other kind of angles. So notice the angle, let's see here, angle LHE. That is not a central angle because the center of the circle is right here. So that's off the center of the circle, and that is not an inscribed angle because it does not touch any part on the edge of the circle. Okay, so angle LHE, we're going to find the angle measure of that one. So notice how we have this question mark here. Our vertical angle rule still applies, so this angle G question mark F, okay, that is the same as angle LHE. Those are just vertical angles, so those are congruent. So if we know H, then we get the question mark angle for free. Okay. But there is still a relationship we can use to figure out what this angle is. So whenever we have two chords in a circle that intersect inside of the circle, all we have to do is we have to add up these outside arc measures and then cut it in half, and that's going to give us this angle measure. Okay. So if we had to make an equation for this one, we would just say question mark, the angle we are looking for is just equal to arc GF plus arc EL divided by 2 equals the angle we're looking for. So we have everything we need. Let's just go ahead and plug it in. So instead of saying arc GF, let's just use 110 degrees. So 110 plus 70 divided by 2. And then it's just a matter of plugging that into your calculator or just using some mental math. That gives us 180 over 2. All right, then half of 180 is just 90. Okay, so we know that this angle measure right here equals 90. Therefore, we could also say angle LHE equals 90 as well. All right, let's take a look at another one. So we have arc UD, we have angle SRT, but what we don't have is we don't have this arc measure. Okay, but we can make an equation to figure that out because we know arc UD plus arc ST divided by 2 equals angle SRT. Okay, so that is an equation we can use to solve this problem. We have everything, so we know what arc UD is. That's just 30 degrees. 30 degrees plus. We don't actually know what ST is, so we can just leave that ST. Anytime we don't know what it is, we can just leave it as is. But we still have to cut that in half. That equals angle SRT, which in this case is 105. Now we just have to use a little bit of algebra to solve for arc ST. So just multiply both sides by 2. We get 30 plus arc ST equals 210, and then you subtract away your 30 degrees. We're left with arc ST equals 180 degrees. All right, now the next one looks like we have to use a little bit of algebra. So the measure, let's see, we're given this picture and some side information. Measure of arc, QBR. So that's 3 letters. Okay, so we have, oops, I forgot to put the B right here. Okay, QBR. So starting at Q, passing through B, and ending at R. This whole arc is equal to X plus 190 degrees. So I'll just go ahead and draw that in. This entire arc was X plus 90. Okay, we have angle QPR equals 2X plus 121. And then we have arc SC equals X plus 52. We can make an equation out of this. We know arc SC plus arc QBR. Okay, so these two opposite arcs, we add them together, we cut them in half, that equals the angle between them. So that equals angle RPQ. All right, and now it's just a matter of plugging in everything we know. We know SC, X plus 52, plus X plus 90, X plus 190, divided by 2, equals 2X plus 121. And so there's 2 ways we can go from here. We can combine like terms on top and then cut it in half, or we can combine like terms on top and then just multiply the 2 over. Whichever way you want to do is fine, doesn't really matter. We got 2X plus, it looks like 242 equals, here's what I'll do. I'm going to go ahead and multiply that 2 over. Equals 4X plus 242. So what we have now is 242 on both sides. That just cancels out. We are left with 2X equals 4X. Well, that's kind of weird. Let's not cancel out the x's. Let's just subtract 2X from both sides. So minus 2X here, minus 2X there. And what we are left with is 0 equals 2X. Therefore, divide both sides by 2 now, and you're left with X equals 0. Okay, so that does seem like a weird answer. Getting 0 is fine. It doesn't happen too often, but we can always check. All right, if we plug in 0 for everything here, okay, so what that gives us is checking our answer. Well, we just go ahead and check it. Okay. We take the opposite arcs and add them together. So when X is 0, that gives us 52 plus 190. We cut that in half, and it should equal 121. Now let's just double check. So 52 plus 190, cut that in half, equals 121. So we are left with 121 equals 121. And that is correct. So X equals 0 is the correct answer. Okay. Now, these are a little bit different because we have a chord and we have a tangent. Okay, and the spot where they intersect is on the outside of the circle. Okay, so on the last ones, we added the 2 arcs together, we cut it in half. On this one, since the intersection is happening on the outside of the circle, what we need to do is we need to subtract these two arcs, then cut it in half, and that's going to equal this angle. Okay, so just a little bit different. So if you wanted to think of like a generic equation, we could say the big arc minus the small arc divided by 2 equals the outside angle. All right, so let's just plug everything in. We know the big arc is 173 degrees minus the small arc is 79. Cut that in half, and that is going to equal angle B, or angle ABC. Okay? So plug that 173 minus 79 gives 173 minus 79 gives us 94. Let's cut that in half. And we have angle B equals 47 degrees. Okay, now this one, a little bit different because they only give us one arc measure and this angle right here. Now keep in mind this is 2 tangents. Okay, so this arc right here, this whole thing, is equal to 240 degrees. Now, it looks like they don't give us enough information, but we know for a fact that an entire circle makes 360 degrees. So if the red arc is 240, then this is just the leftover part that we need to make 360. So 360 minus 240, that just gives us 120 degrees. So we really do. We have everything we need to solve this problem. Okay, so let's just do big minus small. Okay, and cut that in half, and that is going to equal angle x here. So we just have 240 minus 120 divided by 2. That equals angle x. 240 minus 120, that's just going to be 120. 120 divided by 2 equals angle x. Half of 120 gives us 60. So angle x here, 60 degrees. All right. Almost done. So we have a 65-degree arc right here. We have a 120-degree arc right here. But that 120, that's not helping us. We don't want that one. We want the 2 arcs created by the chords and the tangents, or the secants and the tangents. All right, so what we want is we want this outside one right here. So using that same trick like we did up here, whole circle's 360 degrees. We have a arc measuring 65 degrees, and we have an arc measuring 120 degrees. So let's just subtract both of those from 360, and that will give us our missing arc length. Okay, so this arc right here is really 175 degrees. All right, so big minus small, cut that in half, equals the outside angle. So 175, our big arc, minus 65, our small arc. Cut that in half, that's going to equal angle x. So 175 minus 165 gives us 110. And we have to cut that in half. 110 divided by 2 is just 55. So angle x equals 55 degrees. All right, almost done. 2 more. These 2 look a little bit more algebra heavy, but that's okay. So if we had to make an equation, we are going to have arc MJ, this big arc here, minus the smaller arc, minus LJ, arc LJ, cut that in half. That's going to equal angle K. they want us to do is they want us to find the measure of angle K. So after we solve for X, we need to plug it back in and solve for X. So let's look here. So plug in everything we know. So arc MJ is 20x plus 10 minus LJ minus 54. Cut that entire thing in half, and that equals angle K. Well, we know angle K is 6x plus 6. I'm sorry, 6 plus 6x. Okay. So let's combine like terms over here. I'm going to do that same thing again. I'm just going to multiply the 2 on both sides just to get rid of a fraction. So let's see, that gives us 20x minus 44 equals 12 plus 12x. So add 44 to both sides, subtract 12x from both sides. That gives us 8x equals 56. Okay, and 56 divided by 8, divide both sides by 8, that's going to leave us with x equals 7. Now, we are not done because the directions are asking us to find angle K. And so we have to use this. So let's go ahead and plug that in. 6 plus 6 times 7. Okay, one second. 6 times 7 is 42. 42 plus 6 gives us 48 degrees. So angle K is equal to 48 degrees. Okay, last one. We are given TJW, so arc T, starting at T, passing through point J and ending at point W. This equals 18x plus 7. We are given UW equals 7x plus 6, and we have this outside angle of 4x plus 16. So let's set up an equation. There is one thing on this problem where we have to be extra careful. So big minus small, so arc TJW minus arc UW equals angle V. Oops, we have to take this and cut it in half. Arc TJW minus arc UW divided by 2 equals angle V. So let's plug in everything we know. 18 plus 18x plus 7 minus arc UW. Keep in mind, this entire thing is arc UW, so we are subtracting the entire thing minus 7x plus 8. Since there's multiple terms in this expression, we really need to surround it with parentheses because we are subtracting both of these things. If you leave off your parentheses, you're only, when you're running through doing your math, you are only going to subtract the 7x, but you also need to subtract the 8. And a lot of people forget to do that if we don't put the parentheses there. So let's really be careful, make sure we're using all of the parentheses and following the order of operations. Angle B is 4x plus 16. Okay. So let's go ahead and distribute that minus sign in. We do a couple steps here at once. So multiply both sides by 2, get rid of that fraction. We are left with, on the left side, 18x plus 7 minus 7x minus 8 equals, distribute in your 2, 8x plus 32. Let's go ahead and combine our like terms. Let's see, 18x minus 7x, we have 11x minus 1 equals 8x plus 32. Use some algebra, subtract 8x on both sides, add a 1 on both sides. That gives us 3x equals 33. Therefore, x equals 11. All right, but we're not done. Keep in mind the directions. Directions say find the measure of arc TJW. TJW. So we need to take this 11, plug it in right here. So what that gives us is 18 times 11 plus 7. 18 times 11 is it? This equals 205 degrees. And that is our final answer. Arc TJW equals 205 degrees.